Today's experiment is from PH6P1. It's one of your favorite experiments. Using op-amp, we are going to construct the integrator circuit. So we know that op-amp can be used to perform many mathematical operations like addition, subtraction, multiplication, division, differentiation and integration. So we are going to be using it as an integrator. So one of the few things to keep in mind is, the first thing is, whatever waveform you give it in or whatever is input, you will always get the integral of that as the output. So for example, in our case, if we give a sine wave, we'll get output as cos wave, and if we give our input as square wave, we'll always get a triangular wave. And another thing to keep in mind is, we'll always get it as inverted because we are using the inverting terminal of the op-amp. We are going to plot the experiment value and theoretical value of the experiment. I'll explain how to get these, but just keep in mind that for first few values you will be having some kind of deviation, but eventually it will all line up to some value. So now we are going to look how to take the theoretical value. For theoretical value, you just need to remember these two formulas. The V0 is equal to VPB by 2 pi f R1 CF, and V0 is equal to minus VP by 4 pi R1 CF. This V0 is for when you give the input as sine wave, and this is for when you give the input as square wave. Now the CF and R1 is basically, it's your R1 is 10 kilo ohms and CF is 4.7 kilo picofarads, which is nothing but 4.7 into 10 to the minus 9 farads. So now what you do is, you're going to give a range of frequencies going from 100 all the way to 10,000. So 100, 200, 300, 400, 500, and once you reach 1000, increment it at 1000, and correspondingly you will plug in the frequency values and find your V0 for the sine and square wave. And this VPP is basically your peak to peak voltage. So in case of any sine wave or square wave, while you give the input, your peak to peak is basically this and this. The sum of this and this is your is your voltage, peak to peak voltage. And for square wave, it's the same thing. So from this to this, add these two values and you'll get your peak to peak voltage for square wave. But in the experiment, you're going to make sure that your VPP is 2 volts for both the cases. This is your input VPP, which is 2 volts, and this is your V0 PP, basically your output peak to peak voltage, which again you take in similar way. So you measure this distance and this distance and you add them, so that's your output VPP. And in case of a square wave, that's whose output is triangular wave, you measure this distance and this distance, add them, so that's your triangular wave peak to peak voltage. So this is the circuit for the experiment. So one thing to keep in mind is, your audio oscillator channel 1, your channel 2, your pin number 3, and your pin number 6, where after connected to the load resistance is grounded to same point. I'll just explain how the circuit goes. So first we're gonna take the audio oscillator and we are gonna connect it to the 10 kilo ohms of resistance, which is our R1. So in this audio oscillator or whatever, always black is negative and the other color is positive. Assume it to be positive even though it's not rightly colored. So now you're gonna take the audio oscillator, you're gonna ground it, you're gonna connect it to some ground point, and once it's grounded, I'll tell the next one. And the other end of the audio oscillator goes to 10 kilo ohms of resistance. Now we're going to take the channel 1, you're going to take the channel 1 audio oscillator, you're going to connect the positive end of this to the same as your audio oscillator here, and you're going to ground it to a common. So where you have connected your ground of audio oscillator. From that point you just take this to the common over here, and so basically all these points are now grounded, so you can connect any ground points over here. So this is grounded now. Now the next step is, from the 10 kilo ohms resistance, you're gonna connect it to pin number 2. So pin number 2 is here, so you connect it pin number 2 to this one. We are gonna take a short. So this is 10 kilo ohms, so this part of the circuit is done. Now from 2 kilo ohms, since there are going to be other connections, I'm just connecting this over here. Now from this point 2, we are going to connect it to so from this point 2, we are going to connect it to parallelly to the 100 kilo ohms resistance and 4.7 kilo picofarads capacitor. So from point 2, first we are going to connect it to 4.7 kilo picofarad resistance, and another point to 100 ohms, so 100 kilo ohms resistance over here. And now from those 2 points we are connected it to 0.6. So 0.6, this and connect it to 0.6, and the other end of the 100 kilo ohm resistance we're going to connect it to 0.6. Now from 0.6 we're going to connect it to 10 kilo ohms of resistance. So how we're going to do is again using wires, no joke. So this is connected to 10 kilo ohms of resistance, and from that point we are gonna connect it to the ground. So here, and next what we're gonna do is we're gonna ground the point number 3, which is after grounding point 3 it becomes an inverting op amp. And then channel 2, we're gonna ground the negative. So we are gonna connect the 0.4 to negative 12. After doing the connections, switch on all the things, and we keep the audio. For the initial adjustment is you keep the sine wave at 1 kilohertz, and so when we set this to 1 kilohertz, we can see over in the CRO there is some. Okay, first thing, this is the input wave and this is the output wave. So we're gonna adjust the amplitude on the generator such that its peak to peak voltage is 2 volts. So what is peak to peak is, again, as I told you, this peak to this peak, this voltage is the peak to peak voltage. So we have set channel 1 to be 1 volt. So over here each box is 1 volt. So we're gonna adjust the amplitude over there such that the peak to peak is 2 volts. So upper half is 1 volt, lower half is 1 volt. Now next what we are gonna do is I'm gonna show how to take the readings. So a simple way to take a reading is, first set channel 1 to ground and adjust it to some origin line over here. This is the origin line I'm taking it as, and then we're gonna do the same thing to channel 2, and this is the origin line. Now what we're gonna do next is we are gonna adjust the wave such that the sine wave is at 0. So this is at sine 0. As you can see, integral of sine is cos, and this is a cos wave. So we are getting a cos wave, and the wave over here is phase shifted. You can see this if you want. So if you bring this together, you can see there is a slight phase shift. So now to take the readings, you adjust it to the origin, and then you increase the amplitude of channel 2, so at your convenience. So I am taking this as, I am adjusting it to let's say 0.2 volts. So each small box is 0.2, and the way I'm going to take reading is, first I'm going to take the reading for the upper half and then the lower half. So upper half is at like 0.2, and this is cutting at so each small division is 0.05, so this is almost like 0.3. Sorry, each small line is 0.04, so it's almost at let's say point, this is at almost 0.24 or something, and the down one is at 0.24. Okay, so my mistake. So each small division is 0.4. So here the lower half is at almost 0.4, 0.8, 0.12. So this is 0.2 and this is 0.32. And your upper half is also at, again, almost the same thing. So it's another 0.32. So the peak to peak voltage is 0.64. So now next what you're gonna do is, you're gonna start from 100 and work your way up till 1000, and as you can see, at your convenience you're going to take the readings. You're going to adjust your time frame such that you get the cut. So now the last part after taking the reading is to plot the graph. So we're going to draw the graph for both the wavefronts. This is the sine wavefront and this is square wavefront. Along the y-axis you're going to take the voltage, and along the x-axis the frequency, and you're basically plotting all of this in a logarithmic graph. So all the best for that. You figure it on your own how to plot it easily. And this is the square wavefront, and you will again, you can see that there is a deviation at the start, but as and when it approaches to some like around 1 kilohertz, it is almost becoming, both the points are coinciding. So yeah, that's the experiment done and dusted. So you're gonna adjust and you're gonna take the readings and then go to the next reading. So you keep going to next reading till you get to 10,000, and after you get to 10,000 you're gonna change your waveform to square wave. So now this is your square wave, and as you can see you're getting a triangular wavefront, and that's the experiment part of taking the readings.